Hello and welcome to lesson 4.1, 4.2, rates of change of sinusoidal functions. So recall that a sinusoidal function are functions that have graphs that are in the shape of a sine wave. So to start understanding the instantaneous rates of change of sinusoidal functions, we're going to explore the function f of x equals sine x. So remember that this is the graph of y equals sine x, or f of x equals sine x, in radian mode. Okay, so some things to notice. It has zeros at negative pi, 0, pi, 2 pi, negative 2 pi. So multiples of pi. The slope at the spots, well, the slope at 0 turns out to be a slope of 1. Therefore, the slope at 2 pi is also 1. And negative 2 pi, also 1. Because of their symmetry, slope right here at negative pi is negative 1. And the slope right at here at pi also turns out to be negative 1. So what I'm going to do is I'm going to first list these points as my new graph. So my slope are going to be my y values, and my x values are going to stay where they are. Okay. Also looking at the original function, slopes at the maximums are 0. Slopes at the minimums are also 0. One of the definitions of local maximum or local minimum. So we're going to use those values as my zeros for my new graph. And now we're going to draw a curve that goes through all these points as best as we can. Now, as I draw this curve, you're probably realizing, oh, I know what curve this is. Do you guys remember what this curve is? This is cosine x. And this turned out to be the derivative of f of x. So that's something we notice. So the derivative of f of x, if it's sine x, f prime of x turns out to be cos x. By a similar process, you can also figure out the derivative of cosine x. Derivative of cosine x actually turns out to be negative sine x. These are just two trigonometric identities that you need to memorize. There's no other process about it other than going through what I just did. So we're going to use this to help us find the derivatives of these two functions. So to calculate derivative of f of x equal to 3 cos x, well, you can use your constant rule. Leave the 3 alone. Derivative of cos x is negative sine x. Multiply. And you get negative 3 sine x. Derivative of h of t would be h prime of t. Derivative of sine t is cosine t. Derivative of cosine t is again negative sine t. So So this derivative turns out to be cosine t plus sine t. And what you start to notice is derivatives of sinusoidal functions actually turn out to be cyclical in nature. In other words, they seem to happen again and again and again and again. Okay, so find the equation of the tangent line to the function f of x equals 4 sine x at x equals pi over 3. Okay, so in order to find the equation of the tangent line, we need to first find the derivative. So that would just be 4 cos x. To find the slope, I have to substitute pi over 3n. Okay, well, I'm going to refer to my stuff from advanced functions. If this angle is pi over 3, this length is 2, this length is 1, this length is square root 3. So that means f prime of pi over 3 is equal to 4 cosine of pi over 3. Cosine is adjacent over hypotenuse, so that's 1 over 2. So this is 2. So my slope is 2. Okay, I also am going to need to figure this out. F at pi over 3. So that means 4 sine of pi over 3. Okay. Again, using the same triangle, that means sine of pi over 3 is square root 3 divided by 2. So f at pi over 3 is 2 root 3. So now I can work this out. So using y equals mx plus b, y in this case is 2 root 3, my slope is 2, my x value is pi over 3, and add b. So b is going to equal 2 root 3 minus 2 pi over 3. Probably best to use exact values here, so therefore the equation of my tangent line is y equals 2x plus 2 root 3 minus 2 pi over 3. And there we go. Thus concludes our lesson.